So now we're ready to check out example 2. Notice the directions divide. And in part A, we have 3x squared plus 10x plus 5 divided by x plus 2. Now, first off, I need to warn you about something that sometimes people try to do on this problem. Sometimes people look at this problem and they say, oh, I remember from last time that if I divide by a monomial, I can go ahead and break this into 3 smaller fractions and move forward. However, that technique doesn't work because we're not dividing by a monomial here. Notice that our denominator is x plus 2. X plus 2 has 2 terms. We have the x in front of the plus sign, we have the 2 behind the plus sign, so that means that we're dividing by a binomial. We cannot use the technique from last time because the technique from last time only works when we're dividing by a monomial, a one-termed polynomial. This is a 2-term polynomial, so I can't use the technique from last time. So we're going to have to go ahead and use the technique that you just read, the idea of polynomial long division. So in order to do this polynomial long division then, let's go ahead and step through that 6-step process. So step number 1 then says, let's make sure that the numerator and the denominator are arranged in descending order. So let's check out the numerator individually. We have 3x squared. The highest power of x in this problem is 2. And then as I look at the next 2 terms, I do go downhill. So I have a power of 1, and then I have my constant term. So the numerator is written in descending order. Well, let's check out the denominator. As we look at the denominator, the highest power of x in the denominator is 1. And we go downhill from there. So yes, the denominator is written in descending order as well. Now there's a second part to step number 1, and it says we also need to make sure that every power of x is accounted for. So here we have an x squared. The next power down, if we go down by 1, would be x to the first, and we have one of those. Next power down would be our constant term, we have one of those. And the same thing happens in the denominator. The highest power of x to the first, and then every power below that is accounted for. So we're in fact done with step 1. So now we're ready to go ahead and take this problem, and instead of writing it as a fraction like we have it here, we can go ahead and divide it in that division tableau like we did earlier when we were doing the division for the integers. So I can go ahead and take my numerator, the 3x squared plus 10x plus 5, and I'm going to put that under the division bracket. And then I'm going to take my denominator of x plus 2, and I'm going to put that outside the division bracket. Now, we talked about 4 different words earlier for the problem involving integers. Let's go ahead and use those same words when we look at this problem. 3x squared plus 10x plus 5, the polynomial under the division bracket, that was called the dividend. And the polynomial on the outside over here is called the divisor. So now that we have the dividend and the divisor, remember that the quotient then is the piece that's ultimately going to be written above the division bar. So now that we have these 3 words in place, let's go ahead and check out our next 3 steps. So one of the comments that I made earlier was that when you think about division involving integers, it was always 3 pieces. You would think about how many times does somebody go into that particular number, then you would do a multiplication, then you would do a subtraction. It's the same here in the world of polynomial division. So the first big question I'm going to ask is, how many times does x plus 2 go into 3x squared plus 10x plus 5? Once I have an answer for that, I'll do a multiplication, and then I'll do a subtraction. Now, in order to answer that first question, though, I really do focus my attention a little bit more. So instead of asking how many times does x plus 2 go into this entire polynomial, I actually just focus in on the first term of the divisor and the first term of the dividend. And my question becomes, how many times does x go into 3x squared? In order to answer that question, I'm actually going to go off to the side and just write that as a small division problem. 3x squared divided by x. Well, using my rule of exponents, I know once again that this is going to be a quotient rule problem. X to a power divided by x to a power. I'm going to subtract those exponents, and this is going to be then 3x to the first. So I have an answer now of how many times does x go into 3x squared? 3x. So now I need to write down that 3x in the quotient area. However, I don't want to write this 3x just any old ways. I want to make sure that when I write down my division, that everything is lined up. So I want all of my x squareds to be lined up in this x squared column. I want all of my x's to be lined up in this x column, and I want all of my constants to be lined up in this constant column. So because my answer here was 3x to the first power, I want to line that up so that it is hanging out in the same column as the other pieces that had x to the first as well. So I'm going to put that 3x above the 10x because it has the same power. So now the question then is, well, okay, if I was doing that integer division, the next step was I would do a multiplication. Is that the same thing now? Yes, and that's what step 3 tells you. We're going to take this 3x and we're going to multiply it times the x plus 2. But you'll notice when you read through step 3 that I underlined the word every. What that means is I need to take this 3x and multiply it times every term of the divisor. Sometimes people look at this and they remember from the previous step, we focused our attention on just the x, and they say, oh, I'm just going to multiply that 3x times that x. Nope. Once you move to step 3, you want to stop thinking about the fact that we focused our attention and think about the entire divisor now. So if I multiply 3x times this entire divisor, the only way that I can do that correctly is to think about it in terms of some parentheses. So I want to take that x plus 2 and put it inside of parentheses. So let's go ahead and do that off to the side. We have the 3x from up above times the entire divisor of x plus 2 in parentheses. That's a distribution problem then. So if I distribute the 3x through to the x, we're going to get 3x squared. And then if I distribute the 3x through to that positive 2, I'm going to get a positive 6x. So now that I have those pieces then, I can write them over here. Now once again, I want to make sure that I line up everything so that the powers agree. So when I write down this 3x squared, I want to make sure that I put that in the x squared column. And then when I write down that positive 6x, I want to make sure that I put it in the same column as all the other pieces that had the x to the first. So there we have it. Now, remember once again from the integer world, after multiplying, you would then do a subtraction. And that's exactly what step 4 is. We want to subtract this polynomial minus that polynomial. Well, we talked about this the other day in terms of subtracting polynomials. It's tempting to just put this one subtraction symbol over here on the left and then write this down. However, a lot of people, when they put that one subtraction symbol on the left, they'll subtract the pieces in the x squared column, but then they don't really subtract the pieces in the x. So remember the comment that I made when we were doing subtraction in the columnar format the other day. My comment was that the best way to do this is to remember that if you have a subtraction like this, you can change the subtraction into an addition as long as you change all the signs in that second polynomial. So this positive 3x squared becomes a negative 3x squared, and my positive 6x becomes a negative 6x. Now that I've done that, I can go ahead and see what happens column by column. 3x squared plus a negative 3x squared, they cancel out. And if things are going well, that should always happen. This first column should always cancel. Well, let's check out the next one. Positive 10x minus 6x, that's going to be 4x. Now, if this was simply a division in terms of integers, then I would be done. I did the multiplication, then I did the subtraction, and then I got an answer down below. But in this world of polynomials, there's the possibility that you have to go through that process of multiplying and subtracting a whole bunch of times. And that's what the next step is talking about. It says that we need to actually keep doing the division until we run out of terms. So notice in our original dividend, we have this plus 5. Well, I need to bring that plus 5 down here. And now, I notice then that I have a new and improved division problem. I need to take this x plus 2 and divide that into the 4x plus 5. So what that means is I just repeat the processes that we just talked about a moment ago. So I'm going to go ahead and erase on this right-hand side so I have some space to put some work. And as I look at this, the first thing I have to say is, how many times does x plus 2 go into 4x plus 5? Again, I'm really going to focus my attention to just the first two terms. How many times does x go into 4x? Well, that's a division problem. 4x divided by x. 4x divided by x, the x's cancel, and I end up getting just the number 4. And in particular, it's a positive 4. So I'm going to come up to my quotient area and write that positive 4. And now I need to multiply that 4 times the entire divisor. So I'll put that down here, 4 times the entire divisor. The only way that I can do that correctly is to make sure that I have some parentheses around that. And again, that means that this is a distribution problem. So distribute the 4 through to the x, we get 4x. Distribute the 4 through to the positive 2, we get a positive 8. So now I can write that here, 4x plus 8. And we have the next step. Well, now I need to subtract these. Again, tempting to just put that minus sign, but again, the safest way is to go ahead and change this into a plus and change the sign of each one of those terms in the second polynomial. 4x plus a negative 4x, they cancel out. Positive 5 plus a negative 8 would be a negative 3. So now that I have this then, I've run out of terms in my original dividend. And because I've run out of terms in my original dividend, that means that I'm done with this division problem. I'm not done with the answer yet, though, so I need to make sure how to figure out how to put all these pieces and parts together. In order to put all these pieces and parts together, I'm going to start by writing down one more word. We have dividend, we have quotient, we have divisor. Well, this negative 3 that we just found down here is the remainder. So now that we have this then, notice above the steps that I gave you, I said that in this section, every time we write down a final answer, we're going to have dividend divided by divisor is equal to quotient plus remainder divided by divisor. So the original problem here, I have the dividend divided by divisor already written. So let's go ahead and put the equal sign here. And once again, the first thing that we have there is that we're going to write down the quotient. Well, we found that the quotient was the polynomial 3x plus 4. So there's the 3x plus 4. And then the next piece that we're going to write down is plus the remainder divided by the divisor. So we're going to have plus, our remainder is a negative 3, and this is divided by the divisor of x plus 2. Now, as you look at this, it's tempting to say that this is the final answer, but we can actually simplify this a bit. Instead of saying adding a negative, and I can write that with one symbol instead of two. Adding a negative is the same as subtracting. So in general, when you have a remainder that is negative, you go ahead and put the negative like this on the outside. And then we have one symbol instead of two, which makes the problem a little bit simpler. So there's our final answer for this particular problem. 3x squared plus 10x plus 5 divided by x plus 2 is 3x plus 4 minus that 3 divided by x plus 2. Now once again, as you look at this problem, all of these pieces and parts have names. So remember that the 3x squared plus 10x plus 5 was the dividend, the x plus 2 was the divisor, the 3x plus 4 was the quotient, and our negative 3 was the remainder.